So we are going to cover the topic of applications of dimensions, right? So you have any idea like what are the applications of dimensions?
Ma'am, we can use it to check if equations are correct.
Yes, and so there are three applications, right?
Right.
So one, as you said, yeah, now the screen has been shared. Okay. Can you see the whiteboard?
Yes, ma'am.
Okay. So there are three applications. One you said right now, that is to, which one did you say?
To check the consistency of an equation.
Yeah, or you can say to check the correctness of the equation, right? Whether the equation is right, right? So to check the correctness of equation is one of the application. Next, what is it?
To find a relationship between two different physical quantities.
Yeah, you can say to derive the relation between two physical quantities. So derive the relation between physical quantities is also one of the application. And the last one?
To convert physical quantities from one unit to another.
Yeah. So third one is the conversion of unit, right? To convert units. So now we'll start with the first one. And so before starting with the first one, do you have any idea what is principle of homogeneity?
Principle, I've heard of it.
Yeah, okay. So the first thing that is to check the correctness of the equation. For that, you should know what is principle of homogeneity. Now, let us suppose like there is an equation given, right? V is equal to A plus BT. So this is an equation. So what does the principle of homogeneity says? The principle of homogeneity says that the dimension of each term of an equation must be the same.
Yeah.
So this is an expression given, right? So I can write the equation like B minus A minus BT equal to 0, right? So the what does the principle of homogeneity says? The dimension of each term of the equation is the same. So let us suppose this is B is given, this dimension will be same as the dimension of the term A, and that will be also same to the dimension of the term BT, right? So each term will be having the same dimension in any equation, right? Or we can say the principle of homogeneity says that we can add and subtract the same physical quantities. Always two physical quantities, the same physical quantities are added and subtracted. So what does the principle of homogeneity says? The dimension of each term of an equation must be same, or you can say we can add and subtract any similar quantities, physical quantities, right? So using that, what we can find, let us suppose if I ask you, you have to find the dimension of A and B, right?
Yeah.
And what is this? V is given the velocity. So can you find, using this principle of homogeneity, the dimension of A and B? Okay, so what is the dimension of the velocity V?
T to the power minus 1.
Yeah. So dimension of the velocity, it is L T to the power minus 1. Yeah. So you have got the dimension of this velocity. Now what will be the velocity of A? The dimension of A.
Same as B.
Same as B, right? So we can say the dimension of A is same as dimension of V, right? So can you say what is A? A, we come to a conclusion that the dimension is L T minus 1, right? Now what about the dimension of B? So BT, the term BT its dimension will be same, LT to the power minus 1, right? So what do you come if you ask the dimension of B? So B will be what? L T minus 1 upon T, right? This is T, small t is a time. And so what you come? It is L T minus 2. So dimension of B is LT minus 2. We have got the dimension of A, L, T minus 1. So we have used the principle of homogeneity. Each term will have the same dimension.